You are given the following prices for a zero coupon bond that matures for 1 on the maturity date. Josh and Philip enter into a 4-year swap with a notional amount of $200,000. The swap has annual settlement periods. Under the swap, Josh will pay Philip the fixed swap rate at the end of each year, while Philip will pay Josh the variable rate, where the variable rate is the 1-year spot rate at the beginning of each year. Determine the net swap payment at the end of the first year. So we have a 4-year swap, so that fifth year is kind of extraneous here information. The notional amount is $200,000, and hopefully you have a little bit of background on what a interest rate swap is. You're just swapping the interest rate payments, a fixed one for a variable one. So before we find the net swap payment at the end of the first year, we need to find out the fixed interest rate, the swap interest rate. So first of all, because we have zero coupon bonds, it lends itself really well to finding the spot rates easily, because we can just say that for example, in the first year, I start with this much money and I accrue interest for 1 year at the 1-year spot rate, and it matures for 1. So that's how you want to think about it, right? And then, same idea for the second one. The only difference is we have to square it because it happens for 2 years. So it's all about the term structure of interest rates. And like I said, I'm assuming you have a little bit of background on this stuff, because if you don't, it's going to be like, what is he talking about? Right? And I might as well go 1 more year because we have a 4-year interest rate swap, right? Excellent. So that's what's going on. I'm going to introduce some notation here because it's going to be easier to write later on. So if I say v sub 1 to the 1, that means it's like dividing by the spot rate, this expression, but I can multiply it by instead, right? And so on and so forth. Hopefully you see the pattern pretty clearly now. So on and so forth, okay? Great. So let's draw a timeline of what's going on. We have 0, 1, 2, 3, and 4. Okay, let me actually space that out a little better, sorry. So 4-year, and then let's put Josh at the top. Josh is going to pay the fixed rate, so Josh is the payer. Philip is the receiver. You honestly might even see a question like that, multiple choice, because those type of questions occur where, you have to know the difference between a payer and a receiver, so be careful. Anyways, so Josh, each year, the notional amount is $200,000. I'm just going to write it as N. Each year, he's responsible for paying the notional amount times the interest rate. Notional amount times the interest rate. Notional amount times the interest rate. The notional amount is going to stay as $200,000, essentially the loan balance is, because think of it this way: it accrues interest in 1 year, and they pay it off, so the balance is still $200,000. So that $200,000 is still used to find the interest for the next year, and then we have, of course, this. Okay, so that's how much Josh has to pay each year. Now, let's find the present values of these payments. So I have to multiply by the discount by the 1-year spot rate, discount by the 2-year spot rate, discount by the 3-year spot rate, and discount by the 4-year spot rate. I hope that's clear. Okay. Now, what about Phil? Phil's paying the variable rate. So the variable rate is going to be the notional amount times the forward rate, because that basically represents the variable rate that he's paying. It's going to change. And then, of course, we discount again. Okay. Same idea. He's going to pay the notional amount, but this time it's the forward rate because that's the variable interest rate. Each year is going to be different, and that's these expressions right here. That's going to be the different interest rate he pays each year. And then, that's why it's called variable, right? I would do this much quicker, but I'm just trying to show it clearly and take my time here if I were taking this myself. So forward rate from 2 to 3. And there's definitely a shortcut that I'm aware of that, you can solve this problem very quickly, but it's important to understand it from first principles first, and then that'll make the shortcut make more sense, because otherwise it just has no context, in my opinion. Plus the notional amount. Sorry, there's no reason to add it yet. In 4, it's going to be the notional amount times the forward rate from 3 to 4. And then I have, I don't have room, so v sub 4 to the fourth. Okay, so what's our strategy to find the fixed interest rate? We're going to sum the present value of these. We already have it in terms of present value. We're going to sum these, and they're going to be equal to each other. The present value of the fixed interest rate payments is equal to the present value of the variable interest rate payments. Now, here's one really interesting thing I want to point out. We can create a little bit of a shortcut here because, for example, if I have the forward rate from 1 to 2 times v sub 2 squared. Now, that is going to equal, I'm just going to tell you the pattern. We look at this, and then you make it v sub 1 to the 1 minus v sub 2 to the 2. Okay, that's not magic, but see for yourself, because the forward rate from 1 to 2 is equal to this is how it's defined as, right? This is how you find it. So anyways, that's what this is equal to. And then if I multiply that by v sub 2 to the 2, which is equal to this, you'll see that you should get this, okay? But it's not the point of this video, not to dwell on the derivations here. It's to understand that can always be true, or see that it's always true. So for example, if I have the forward rate from 2 to 3 times this, it's just going to be v sub 2 squared minus v sub 3 to the 3. Okay? So convince yourself that it's true, because it is, but that's going to save us some time. So let's go for it. Let's set the present value of these Josh's payments equal to the present value of Phil's payments. So NI, the notional amount. Yes, and I'm aware that you could have not even included the notional amount, but I want to show this from first principles first. Okay, it's times v sub 1 to the 1 plus NI. I'm just not going to color code it anymore. It's not really necessary. V sub 2 to the 2 plus notional amount times v sub 3 to the 3. It lends itself well to an easy pattern. Also, you can see how it's being written. So that's the present value of Josh's payments, interest payments, and that's going to be equal to, now we're going to use that technique that I talked about, okay? We're going to turn it into a telescoping sum. So the notional amount times v sub 1, v sub 0 to the 0 minus v sub 1 to the 1, okay? Plus the notional amount, same thing we're going to do here. V sub 1 to the 1 minus v sub 2 squared plus the notional amount times v sub 2 squared minus v sub 3 cubed, because I'm right here. And then finally, notional amount times v sub 3 to the 3 minus v sub 4 to the 4. Okay, now this is why we didn't need the notional amount, because I can divide everything by n, the entire equation, I should say. So the n's cancel out. Works out really nicely. And not only that, this is why we wrote it as a telescoping sum, because look at this. Gone, right? Minus, and then this is gone. And then this terms disappear. And then this is 1. V sub 0 to the 0 is just 1. So this side turns into 1 minus v sub 4 to the 4th. And I can just factor out the interest rate, of course, and then say it's v sub 1 to the 1 plus v sub 2 to the 2 plus v sub 3 to the 3 plus v sub 4 to the 4th. Okay? And obviously you should see by now I can find the interest rate. The interest rate is going to be equal to 1 minus v4 to the 4th all upon v sub 1 to the 1 plus v sub 2 to the 2 plus so on and so forth. It looks kind of messy, but it's really not that bad, It's just a simple idea here. Okay? And remember what these values represent. We have them easily because we can find them easily because we have a zero coupon bond. So then I'm going to say 1 minus, what's v sub 4 to the 4th? Remember, it's based on this idea. So it's going to be 1 over 1 plus s4 to the 4th. Okay? So it's just going to be, if you think about it, it's just going to be 0.825, isn't it? Because look, 1 plus s4th to the 4th equals, so it's 1 divided by this, obviously, so 0.825 to the -1, right? So if I make this a negative, this has to be a positive. So that's it. So think about how easy that is. I can just subtract the price of the bond. Okay. And what's the 1 year? Well, think about it. It's going to be just 0.965, isn't it? For the same reason. It's if the 1 year spot rate is 1 divided by this, 1 plus S1 to the 1, then the discount factor has to be reciprocal of that, which is just 0.965. So these are just the prices of the bonds, but it's important that you see why, okay? It's not just magic. That's where the shortcut comes from, you know? You can just take 1 minus the last year, which would be year 4, and then subtract the price and then add up the prices of, but that makes it seem like magic, you know, in my opinion. You have to see where it comes from, and then it'll become clear why we can use this. You know, so by the time you take the test, you want to do the problems quickly, of course. I'm not saying be all theoretical here, but you know, it should be clear where this comes from, right? This is the discount factor v sub 3 to the 3, and then plus 0.825. Okay, so sometimes you see a shortcut in terms of bond prices that gives it to you like this, but it can easily be derived. Okay, so how am I getting v sub? Remember, it's based on this idea, and you know, so we need to understand that idea. Okay, great. We can find the use your calculator. We're going to find the fixed swap rate. So 4.9% is what I got. Okay, so the interest rate is 4.9%. Okay, so the first year, Josh is going to pay 200,000 times 0.049, right? And he's going to receive from Phil 200,000 . So what was the forward rate from 0 to 1? You know, that can easily be found because it's just the 1 year. It's just like the 1 year spot rate. So it's going to be 1 divided by 0.965 minus 1. Okay. So it's 3.6%, right? So 0.036. So think about it. Josh pays this much. He receives this much. So what's going to happen? Josh is obviously going to pay more, right? And so just to 200,000 times 0.049 minus 0.036. Okay, and then we get a 2,600. I rounded my swap interest rate, so it's not that accurate, but if you do it more accurately, you should get a much more accurate answer. Okay, good job.